The timeline that we would expect to see a Hyperloop working, I could say 2028, in 5 to 6 years.
That soon?
Yes.
Hello, I'm Sue Nelson, and welcome to the Create the Future podcast, brought to you by the Queen Elizabeth Prize for Engineering, celebrating engineering visionaries and inspiring creative minds. Imagine a ground-based public transportation, but one that would enable you to travel close to the speed of sound and journey from England's south coast to the northern tip of Scotland in just 1 hour. It's called the Hyperloop, and a number of companies are trying to realise this high-speed system, including the California-based Hyperloop TT. And my guest is the company's Propulsion Levitation technical lead, Dr Siavash Sadeghi. An Iranian-American, he has a science degree from Isfahan University of Technology and a master's from Amir Kabir University of Technology based on hybrid electric vehicle motors, as well as a PhD from Georgia Institute of Technology in the US. And I began our conversation by asking him to explain the concept of a Hyperloop in more detail.
Hyperloop is a fast electric train, but we are shooting a capsule inside a low pressure tube. So reducing the resistant forces, especially from aerodynamic drag, we can shoot the capsule with higher speed, because the only resistance in higher speed is the aerodynamic drag from air. So if we reduce that one inside our low pressure tube, we can accelerate the capsule up to 1200 kilometer per hour.
And how does it differ from, say, a monorail, which is the first thing I think of that involves levitation, which is, part of your amazing job title?
Yes, we have different levitation system. We have Shinkansen, and also we have Transrapid. They are all based on maglev system, but they are not inside a low pressure tube. So they are always face the resistance of the air. They cannot go to higher speed. So the maximum speed that they can achieve is up to 400, 500 kilometer per hour. Above that is almost impossible with not using the low pressure tube. In this case, you need a lot of power to push the capsule forward. But in our case, we reduce that air pressure so it can give us this ability to go to 1200 kilometer per hour.
And that's purely from having this low pressure then. That's the key difference.
Yes, we are using the same, almost similar levitation system. So we levitated, but from the speed and from the propulsion system, we use low pressure environment to increase the speed.
And how do you lower the pressure in this tube?
We have strong vacuum pumps that we connected to our tube, and we place them along the tube and along the guideway, and we suck the air from the tubes and to create the low pressure environment.
Your company is using something called Inductrac. What is that?
Inductrac basically is a passive levitation system instead of active system. So there is no power into that. Easily we are just pushing a bunch of permanent magnets over a conductive plate. And when we push arrays of magnets over a conductive plate, it's gonna levitate. This is called Inductrac. This is a passive levitation system. Instead of energizing, putting the active power into the coils and create the levitation and forces, we just use the permanent magnets pushing over the conductive plate.
And where does your technology get involved in this process?
The baseline Inductrac is using an array of permanent magnets moving over a lateral type guideway or conductive plate. So when the array of magnets are hitting those empty spaces on the lateral track, it creates some oscillations. In my patent that I filed for Hyperloop TT, we arrange the magnet on the mover somehow that we are going to damp those oscillations, and we get a smooth force which impacts on the passenger's comfort and also the smoothness of the drive.
You've also got this smart material called vibranium, which obviously any fan of Black Panther will know is a sort of mythical element. Where does this vibranium come in?
Vibranium is a special material that we use for our capsule body. It has a specific features that make it lighter, make it more strong, and make it possible to move at 1200 kilometer per hour. Our capsule material is a dual layer composite material using vibranium.
What a publicity stunt then to say that you've got capsules made of vibranium. On what stage are the whole concept at the moment? Is it still on paper, or are you working towards a working model that can be demonstrated?
That's a very good question. So at this stage, we have built a 320-meter tube in Toulouse, France, and we already tested the vacuum, and we vacuumed the air inside that 320-meter to almost 10 Pascal. So we tested that one on the propulsion and levitation. We have done quite a job, and we develop our concept, our linear motor system, our levitation system, and we started some prototyping already. We have prototype 1 meter of our motor already, and we are testing that one in Toulouse, France. It's a huge concept. If we look at this technology, our motor is going to provide about 10 to 12 megawatt power. So it's not only 1 meter machine, right? It's going to be a series of motors connected to each other to create that much power. If you look at the capsule itself, to lift the capsule, we need about 600 kilogram of magnets under that to just lift the capsule. So it's a huge project, but we are doing some prototyping. We are working on stability analysis and designing our damping system and suspension system. We are working with experts in different countries to develop our suspension and damping system, to not going through the path that previous company have gone. We are getting feedback from Lewis Livermore National Lab. We are getting feedback from General Atomics Inductrac too. We are using those feedbacks, and based on those feedbacks, we try to go to the analysis that can lead us to stability, because stability is the most important part in Inductrac concept.
It's no coincidence that the company you work for was founded the same year that Elon Musk set out this big challenge to everybody to rally round this technology and get this Hyperloop built. Is Elon Musk a personal inspiration for you as an engineer, or is there someone else that really fired your love of what you do?
I got interested in engineering, and especially on the motors and controls and electronics from high school. I chose to be electrical engineer at that time, going through best schools in my country and coming here for the PhD to continue on this subject. I always looking for new technologies. If you look at my background, I always challenging myself by moving from one company to other company to just test different technologies. From automotive to medical to energy generation and aerospace, and then transportation and hyperloop. I always looking for technology, but for Hyperloop, yes. So it was Elon Musk when he was talking about bullet train and going to 1200 kilometer per hour. It was insane. And when I reached out by a recruiter at Hyperloop TT, I said, "Oh, that's the one I was looking for, joining a company to develop the technology that it's way beyond the market right now."
Yes, even though levitation and this form of technology that it's based on, and I know that the low pressure is new, that's been around for quite a while, but there is something futuristic about it, isn't it? Is that what appealed to you, that you're taking the technology further?
Yes, actually, there was some cartoons. If you look back in 1940, also some sketches from different people that they were talking about this concept. So it's not new, right? But if we look at the speed, we are talking about a speed of sound, right, on the ground, like airplane on the ground, but much quieter, smooth, low noise, and very clean. Actually, it's a clean energy that we can use. It's kind of futurist, and that's why only 1% or 2% cannot design the Hyperloop, in my opinion. It's a work that many partners from different industries should be involved to do part of that, and just putting all these pieces together to make it happen.
And what is it about motors that's kept you so interested for 25 years now?
Yes, first of all, it's a clean technology, right? So look at the electric vehicles, right? So you are removing the pollution from your electric vehicle when you start it in your garage. This is beauty of the electric motors, right? The electric motor, when I was in bachelor degree, I was working with those machines. When I'm looking the performance, when I'm looking at their technology that they have, that you can create different design, you can create different performances, you can have linear type, you can have rotary type. These are interesting for me, and when I'm looking at this technology, it's interesting. That's why I always be with the motors and controllers and inverters.
Absolutely. And I noticed among your qualifications that you have a certificate in inventive problem solving, which, rather like your job title, is another fantastic title for something. Yeah. Now, what does that certificate actually involve? Can you teach somebody to be inventive?
We had a training session with a company called Trees. And at Trees, actually, they were teaching us how we can solve the problem with the simple method. So we formulate basically the problem, and based on the what we have, what methods we have, what is now in our hand, how we can solve that problem. It's a very interesting method. It's called TRIZ, TRIZ. And when we were facing a problem, we just formulate that one. There are some equations. You answer to some questions, and based on that, at the end, you will find the answer easily.
Now, you mentioned that, you'd moved. The reason you'd made so many moves was to sort of stretch yourself, and you've worked at General Motors, Honeywell, and which was the sort of job that you did that you think, gosh, I learned a lot from that one, and that pushed me to where I am today?
Honestly, each company I learned a lot. And always when I go to an interview, they ask about that. I'm saying that in each position, I learned a lot. I was always working on new things. And when that new things was ended, I'm just leaving that company and going to another company. So in General Motors, what was fantastic, working with an expert over there on the motors and controllers. And then moving to Honeywell, working on the aerospace and airplane and the power electronics and motors that they are going to use in aerospace. It was amazing. They have different requirements, they have different capabilities, they need a special design. Then moving to Hyperloop, right? So Hyperloop was different area that I was looking for, because I was moving from rotary electric motors to linear electric motors. That was new and also very challenging for me. It opens another door for me.
You may be aware that the Queen Elizabeth Prize for Engineering 2022 was awarded to Dr. Masato Sagawa for his pioneering work in permanent magnets. How crucial a role do they play in Hyperloop technology?
Yeah, so the heart of the Hyperloop is the propulsion and levitation system. Basically, the system and mechanism that we are using for the levitation and the mechanism that we are using for pushing the vehicle. Both are usually using permanent magnets, and permanent magnet is very important for Hyperloop and Hyperloop technology. The reason behind that is that you cannot get the power density required that you can get from permanent magnets from other technologies. For sure, we are also doing some research on non-magnetic propulsion system to see if we can replace those permanent magnet machine with non-permanent magnet machine, as we, as I did for other companies, to basically save the magnets somehow on the propulsion system. But at this moment, we haven't had a design that we can use with non-magnet mechanism.
Now, you are from Iran. What sort of an attitude does Iran have towards engineering? Is it a profession that's considered with the respect it deserves?
That's a very good question. You know, most of the motor designer in California, at least I know, like 80% of them are Iranian. In Iran, when we go to high school, there is a pressure from the families that either you should be an engineer or a doctor. And when you want to go to the engineering world, and they are saying that the only engineering that can benefit you is electrical engineering, mechanical engineering, and civil engineering, and computer engineering. This is just mentality over there, that if you want to be successful and you want to get a job and make money in the future, it's best to go to these four basically major in engineering. So most engineers and most students in Iran, when they want to choose their major in schools, they usually go for these four types of engineering.
So it sounds as though it is in the same way as countries like India, where people really do regard engineering as a good profession for a young generation to study.
Yes, that's true.
Is there a different approach, do you find, now that you're living in the United States?
Yes, the United States is different, right? So in the United States, you can be successful almost in any majors, right? You don't have that pressure that you have in Iran anymore. I always talking to my daughter, and she's saying that, I don't like math. I don't want to be an engineer. I said, okay, that's fine. Here is not Iran that we can push our kids to go to engineering or being a doctor, right? But we just provide the environment that they can choose. Basically, this is engineering. I took my daughter to Hyperloop, show her around, look at the Hyperloop. This is Hyperloop technology. And she got interested to that technology. How cool is that technology? And after that, she said, oh, I want to be an engineer. Right. So I didn't push her, but she said, I'm going to be an engineer. I'm going to work on Hyperloop. So looking at those environment and getting kids familiar with the technology is always good. At Hyperloop TT, one of the work that we did in the past was bringing kids and teenagers to the Hyperloop, giving them a tour that they see the technology. How cool is that? Sitting in the capsule concept, and it was very good. It was very motivating for them.
Well, it does sort of capture the imagination, doesn't it? What's your next big stage? Obviously, you've been doing this work in Toulouse and testing the tunnel part of it and getting the pressure right. What will be your next big project?
Yeah, the next part that we are working on, that we are finalizing our propulsion design, our linear motor design, and we are testing our levitation concept with a research center in Italy. Once we get those finalized, then we go ahead with the prototyping. So that 320-meter test track that we have in Toulouse, next step is building the propulsion inside and building a capsule to test the propulsion and levitation inside the 320 meter. But in parallel, we are also working on some feasibility study on the 5 kilometer and 125-kilometer track. Also in US, we did a study on the Cleveland Chicago for 550 kilometer. That feasibility study has been done, and as I said, next stage we are going to prototype our propulsion and levitation system to test it in Toulouse, France.
That's quite exciting, isn't it? And I know this is an impossible question to ask because it's like saying, how long is a piece of string? But when would you hope, in an ideal world, that you'll see a working system up and running somewhere around the world?
The timeline that we would expect to see a Hyperloop is working, I could say 2028, in 5 to 6 years.
That soon?
Yes. Also, we are working hard on the technology with the data that we have, with the design that currently we have. We are hoping that we can have this technology by 2028.
And do you feel as though there's a sort of a bit of a race going on because you're not the only company, obviously, with your eye on making this happen?
Yes, definitely. Right now, this is a competitive market. We have different hyperloops, but I could say we are not competitor. We are friends also. We just want to have this technology in the market so people can use it. We want to have an impact on the climate change, right? We want to reduce this CO2 from the airplane. We want to have a clean energy that we can transport people with the fast speed around the world. And there are different companies working on this concept, and this is a good thing.
So it sounds as though you want to be a part of this in terms of engineers making a difference then.
Yes, for sure.
Siavash Sadeghi, thank you so much for joining me on the Create the Future podcast.
It was my pleasure. Thank you very much.
And you can find out more about the Queen Elizabeth Prize for Engineering by following QEPrize on Twitter and Instagram, or visit QEPrize.org. Thanks for listening, and join me again next time.